Alright guys, so this is going to be a little bit of a lesson here on molarity and stoichiometry in case you missed it in class and you need to see that again, or you need to see it again. So what we're going to do is we're going to take the molarity equation here, and hopefully I'm doing this right here, new program. Molarity is equal to moles divided by liters. Alright, so that's our main equation that we want to remember for molarity. Molarity is a capital M, and so when we read this, what we end up seeing here is that we're looking for the mass of copper, alright, and we want to know how much of that copper will be produced if, there we go, we have this much copper sulfate, all right, 350 milliliters of a 0.5 molar solution. So let's try and tackle this here. Now, the first thing I always like to do is we want to find the mass of copper, right? Copper Cu. All right, so this is what we're trying to find. I always put a box around what I'm trying to find as well as what I know, and in this case, that's the copper sulfate. So I put a box around both of those. All right. So my next thing that I'm going to do is I got to convert this into moles to do any kind of stoichiometry, right? I want to go from this to this, so that's going to require some stoichiometry. So the first step then is it looks like I've got 2 out of the 3 pieces for my molarity here. I've got liters, well, milliliters, but I can convert that into liters. And then they also give me a capital M here. So there's my molarity, all right? So I'm going to solve for moles, and 2 ways I can do that. I could either just plug in the numbers. So, whoops. Zoom in here a little bit. So I could plug in the numbers, and I've got, well, let's just define the variables first. 0.5 molar is my molarity. Moles is what I'm going to find. Okay, so that's X. And then liters, I'm going to have to convert 350 milliliters into liters. So 350 milliliters. And remember, the way that we do that is we take milliliters and we divide it by 1,000. That's going to give us liters. All right. So if I divide this by 1,000, move the decimal point, and I get 0.35 liters. All right. So just to kind of recap here, now I've got 0.35 liters. I've got 0.5 molar. Now I can solve for how many moles that is. So let's go ahead and do that. I'm going to take 0.5 molar equal to X divided by 0.35. Whoops. 0.35 liters. And to solve for X, I'm going to multiply both sides by 0.35. So times 0.35, 1 times 0.35 over here. So my X is going to end up equaling, I think it comes out to be about 0.18 moles, if I do that math. That's what that equals. Okay? So what that tells me is that now that is in, all these numbers are based off of copper sulfate, right? Copper 2 sulfate. So what I can do is I can now convert that. I can convert that, moles of CuSO4. I can change that to copper, right? So the way that I can convert that to copper remember, here's what I start with, here's what I want to end with. And our big key thing here is those coefficients. That's almost like a recipe. It tells us for every 3 parts copper sulfate, we're going to get 3 coppers out of it. Alright, so if you get stuck, you can always start by putting the units on the bottom. Moles CuSO4 on the bottom. Moles Cu is what we want to find. I can already tell I'm going to run out of space. And I look at the numbers here, they're both 3, so for every 3 moles of CuSO4, we're going to get 3 moles of copper out of it. So I'm going to plug in those 3's, 3 and 3. My last step, I got to go to the periodic table because I don't want moles of Cu. My last step here is going to be, oh, and I'm out of space. Let's just pretend like that's down here. If I come down here, my last step is I'm going to have moles of Cu on the bottom. Okay, moles of Cu. And we know that 1 mole, go to our periodic table, it tells us 1 mole weighs 63.5 grams. Okay, so the last thing I got to do, punch it into my calculator. 0.18 times 3 divide by 3 times 63.5 divide by 1, and we should get an answer of, I believe it's 11.4 grams of copper. Okay, so hopefully that helps. Helps you fill out the rest of that sheet. Thanks.